Hello, everybody. Welcome back to another video. In this video, we're going to be taking a look at a question from the IB Chemistry Paper 1HR from May 2021. And this question is to do with chiral centers. And now, what is a chiral center? A chiral center is basically a carbon molecule which has four different groups or atoms attached to it. So a chiral center can look something like this. So as you can see, this carbon over here has four different groups attached to it. All these groups are different to one another, as you can see in very obvious ways, right? So this would be considered, this carbon over here would be considered as a chiral center. Now, this, however, this would not be considered as a chiral center because this does not have four different groups attached to it. It only has two. So these are the two different groups. However, it has two hydrogens attached to it, and that means that it is not chiral or achiral. So this is not a chiral center. Now that is literally all you need to know about a chiral center. That's simply what it is. A chiral center is a carbon molecule with four different groups attached to it. Now, if you plan to take chemistry at university level, and I speak from experience when I say this, a lot of chiral center chemistry comes up. So stereoisomers and chirality, that comes up a lot because it's very important in a lot of different ways, which I won't get into now, but hopefully you will learn about it, some of it in IB and some of it if you plan to take chemistry at university level. So now let's get on with the question. This question is asking us, how many chiral centers are there in the following molecule? Now, a molecule as such, a complicated molecule as such, this is a sugar, it can have more than one chiral center. And it is easy to identify chiral centers when we draw them out like this, but it is difficult when the molecule is in this shape. And I completely understand that because even I find it very difficult. But really, the only way to make it easier for yourself is to practice more until you get the hang of it. And eventually you can do it just by looking at the molecule. And that is the key to solving MCQ questions, right? You have to do it fast because you don't have a lot of time. And these methods and practicing helps a lot. So let's look at this molecule. First, let's break it down, right? We need chiral centers, and chiral centers exist on carbon atoms. So how many carbon atoms are there in this molecule, right? We have 1, we have 2, 3, 4, 5, and 6. Now we can automatically eliminate these two, right? These two will not be chiral centers because if you look at this carbon, right? If I expand this, if I sort of expand this CH2OH, and this is attached to the ring. This is my very bad representation of the ring. Sorry, it's attached over here. So this is CH2OH, right? This is not a chiral center because it has two hydrogens attached to it. That means it doesn't have four different groups. And it's the exact same thing for this one, right? These both are identical groups. So we can eliminate these two carbons, right? They are not going to be chiral centers. So we can eliminate option number D. 6 is wrong. Now we are left with 4 other carbons. Now let's see, do these 4 other carbons differ? Or do these 4 other carbons have 4 different groups attached to them? Well, let's check that out. Let me just erase this real quick so I can draw this out. Okay, let's take a look at this carbon first. Would this be chiral? So this carbon has a hydrogen attached to it. It has CH2OH attached to it. It is attached to an oxygen, and it is attached to this whole part, right? It is attached to this carbon, which is attached to this whole part. So it's a totally new group, right? It is attached to another carbon, which is attached to a hydrogen and an OH. Sorry, I'm just going to draw this very roughly. So as you can see, there are 4 different groups which is attached to this. So it's attached to the oxygen, which is this. It's attached to this group. It's attached to this hydrogen, and it's attached to this whole side, the whole other part of the ring. So I'm just going to keep it as X because it's attached to this whole other part, right? It's attached to a totally different group. So this carbon over here is chiral. It is attached to 4 different groups. So because this carbon is chiral, this carbon is automatically going to be chiral because these 2 sides are identical, right? Except for this OH, of course. This OH is different. But regardless, even this carbon is going to be chiral because it is attached to an OH. It is attached to this other group, CH2OH. It is attached to this oxygen. And again, it is attached to this whole other ring. So this carbon is also chiral. So we can eliminate 2 because we can eliminate nothing so far actually, but we know that these 2 carbons are chiral. What about these 2 carbons? Are these 2 carbons chiral? Well, let's check it out. So this carbon over here is attached to an hydrogen. It's attached to an OH. Then it is attached to a carbon, which is attached to another CH2OH, and it is attached to an OH. Sorry for the messy handwriting. And then this carbon over here is attached to this other group over here. It is attached to this group over here. And this group over here is different to this group over here. That means that this carbon is also chiral. So this carbon is chiral. And if this carbon is chiral, that means that this carbon will automatically be chiral as well because it is attached to an OH and H. It is attached to this group over here, and then it is attached to this whole group over here. So this carbon is also chiral. That means that this molecule over here, sorry for the messiness, this molecule over here has 4 chiral centers. It has 1 over here, 1 over here, 1 over here, and 1 over here. That means the answer is 4. So hopefully that's made sense. I know it's a bit confusing, especially when it's in this format, when it's in this closed ring format. It can be a bit confusing for both to understand and for me to explain, but hopefully you've understood the point. And really, if you're facing difficulty understanding this, what I would suggest is that you open up the molecule and then you take a look at it. So that always makes it easier. It would be a bit longer, but it would make it easier if you would just open the molecule up and then take a look at each individual carbon. So that's it for this video. Thank you so much for watching. Hope I have managed to explain this concept well to you. If you have any other questions, please feel free to reach out to me on my social media or via email. I'm always available to answer your questions. Thank you so much. Take care, and I will see you in another video with another question. Goodbye.